Hello, I am Guruprasad Upadhya, HOD, Department of Mathematics, Canara Engineering College, Bantwal. So this is second lecture in Module 2 of 18MAT41, Complex Analysis and Probability and Statistical Methods. So in the second module, Conformal Transformations and Complex Integrations. Today, so in this lecture, I am going to discuss bilinear transformation. Now, bilinear transformation, or in short form BLT. The transformation W equal to AZ plus B by CZ plus D, where A, B, C, D are real or complex constants such that A into D minus B into C is non-zero, is called bilinear transformation, or in short form BLT. If W is AZ plus B by CZ plus D, then Z is DW minus B by minus CW plus A. That means you are interchanging this A and D here. A and D is interchanged, and change the sign of B and C and replace Z by W and W by Z. This is how we can find Z in terms of W. So it's very simple logic. W is AZ plus B by CZ plus D. Just interchange A and D and change the sign of C and B and replace W by Z and Z by W. So you get Z equal to DW minus B by minus CW plus A. In bilinear transformations, the condition AD minus BC not equal to 0 ensures that the conformal properties of BLT. That means if AD minus BC is non-zero, then bilinear transformation is conformal transformation. We have dW by dz, derivative of W with respect to Z, or f dash Z, equal to AD minus BC by CZ plus D whole square. Just differentiate W with respect to Z. So you will get this. If the numerator is non-zero, means AD minus BC is non-zero, means derivative with respect to Z is non-zero. Since derivative is non-zero, the transformation is conformal. That means derivative is non-zero, means in the conformal transformations, the angle between the two curves at the point of intersection, since derivative non-zero, means you get different slopes. So with the help of that slopes, we are able to find the angle between that two curves. Therefore, the transformation is conformal if AD minus BC is not equal to 0. The cross ratio of set of 4 points P1, P2, P3, P4 is defined by P1 minus P2 into P3 minus P4 by P2 minus P3 into P4 minus P1. That means P1, P2, P3, P4, P2, P3, P4, P1, like that. So with this cross ratio, so this is not about this bilinear transformation, the concept of the cross ratio of the 4 points. Invariant points or fixed points in bilinear transformation is nothing but if a point Z maps onto itself, that means W is also equal to Z for the particular value of Z, then that point is called, Z is called invariant points or fixed points in bilinear transformation. Okay. Now, if W is a bilinear transformation of Z and then Z is also a bilinear transformation of W, and if W is BLT of Z and Z is BLT of T, then W is also BLT of T. So this is properties of BLT. The cross ratio of set of 4 points is preserved under a bilinear transformation. Preserved means that cross ratios of 4 points in W and Z preserves under BLT. So W1 minus W2 into W3 minus W4 by W2 minus W3 into W4 minus W1 is nothing but Z1 minus Z2 into Z3 minus Z4 by Z2 minus Z3 into Z4 minus Z1, where W1, W2, W3, W4 be the image of Z1, Z2, Z3, Z4 under BLT, bilinear transformations. Now, if the three set of points means Z1 and W1, Z2, W2, Z3, W3, Z4, W4, or only 3 points are given, then how to find bilinear transformation? So replace W1 by W minus W1 into W2 minus W3 divided by W1 minus W2 into W3 minus W, that is equal to Z minus Z1 into Z2 minus Z3 divided by Z2 minus Z3, Z1 minus Z2 into Z3 minus Z. That means replace W1 by W and Z1 by Z, and W2, W3, W4 is replaced by W1, W2, W3, and Z2, Z3, Z4 is replaced by Z1, Z2, Z3. Then you are able to find the BLT, bilinear transformation, if the three set of points are given. Examples: find the bilinear transformation which maps the point Z equal to 0, I infinity onto W equal to 1 minus I minus 1, and also find the fixed points, that means invariant points. Now, to solve this problem, I am going to discuss this problem with the two methods. One is direct method, no concept is required. Just assume that W is AZ plus B by CZ plus D. Assume that this is required bilinear transformation, and substituting the given points. Just substitute the given set of points. You will get three equations. When Z is 0, W is 1. Therefore, 1 equal to 0 plus B by 0 plus D means B by D. And Z is I means W is minus I. Therefore, minus I equal to AI plus B by CI plus D. And when Z is infinity, W is minus 1. Therefore, minus 1 equal to A into infinity plus B by C into infinity plus D. So, you will get three set of points. Now, when Z tends to infinity, AZ plus B by CZ plus D is nothing but A by C. Just take the coefficient of that infinity. When Z is infinity, its coefficient is A. When Z is infinity, its coefficient is C. Therefore, A by C. So, it is by LH rule. Just differentiate numerator and denominator, just divide. So, A by C. Now, 1 equal to B by D. So, one equation we got by substituting Z is 0 and W is 1, and W is minus I, Z is I, you get minus I equal to IA plus B by IC plus D, and minus 1 equal to A by C. Or you can write like this: D equal to B, or this numerator B is nothing but D into 1. So, B equal to D, IA plus B equal to minus I square C. Minus I square is 1. We know that I square is minus 1. Therefore, minus I square is 1. So, 1 into C minus I into D. This is second equation, and A equal to minus C. From these three equations, find the two equations involving only three variables. That means eliminate either D or C or B and find two equations. Here we got already one equation not involving D, A equal to minus C. Therefore, find one more equation not involving D. Here B equal to D means replace D by B. Then Second equation becomes IA plus B equal to C minus I into B. That also does not contain D. So we got two equations not involving D, and hence, so we got two equations. One is IA plus B plus IC, or 1 plus IB minus C equal to 0, and the equation 3 is nothing but A plus 0B, no B here, so 0B plus C equal to 0. To find ABC, the simple method that we already studied in 8th standard, just take the coefficients. Here start the coefficient with B and then C and then A, again B. Therefore, B, C, A, B. The coefficient of B in the first equation is 1 plus I, in the second equation is 0, and coefficient of C is minus 1, here 1, and coefficient of A is I, here 1, again coefficient of B is 1 plus I and 0. That means the cross multiplication or just determinant of the coefficient of B and C is nothing but A, and C and B, its determinant is B, and A and B determinant is C. After finding A, B, C, if there is any common term, you can remove or divide, because this is ratio, therefore some common term is removed. Now, to find A, 1 plus I into 1 minus 0 into minus 1. 0 into minus 1 is 0, therefore 1 plus I. A is 1 plus I. B is minus 1 minus 1 into I. Minus 1 minus I is nothing but minus 1 plus I. And C is determinant of A and B, that is 0 minus 1 plus I. Here common term is 1 plus I. You can cancel 1 plus I. Therefore, A is 1, B is minus 1, C is minus 1. Or you can write A is minus 1, B is 1, C is 1. Since B equal to D, D is also 1. So, minus 1, 1, 1, 1. So, A is minus 1, B is 1, C is 1, and D is also 1. Substitute these values in W. W is AZ plus B by CZ plus D. Since A is minus 1, B is 1, 1 minus Z by 1 plus Z. 1 minus Z by 1 plus Z. That is W. Now, to find the invariant points, that means fixed points, replace W by Z. Z equal to 1 minus Z by 1 plus Z. When Z is 1 minus Z by 1 plus Z, Z plus Z square is 1 minus Z, or Z square plus Z plus Z, that means 2Z minus 1 equal to 0. So, you know how to solve this quadratic equation. So, minus B plus or minus root B square minus 4AC by 2A. Therefore, Z is minus 1 plus root 2 and minus 1 minus root 2. These two are invariant points. For these 2 points, W equal to Z. This is how we can find the invariant points. Now, to solve the same problem by one more method, that is by cross ratio method, find the BLT which maps the points Z equal to 0, I infinity onto 1 minus I minus 1 by another method. The cross ratio of set of 4 points is preserved under a bilinear transformation. With the help of this, W minus W1 into W2 minus W3 divided by W1 minus W2 into W3 minus W equal to Z minus Z1 into Z2 minus Z3 divided by Z1 minus Z2 into Z3 minus Z. Now, substitute the value of Z1, Z2, Z3, 0, I, infinity, and W1, W2, W3, that is 1 minus I minus 1. Therefore, W minus W1, that is 1, into W2 minus W3 minus I minus minus 1. So, minus I plus 1 divided by W1 minus W2, 1 minus minus I, that is 1 plus I, into W3 minus W, minus 1 minus W, equal to Z minus 0 into I minus infinity divided by 0 minus I into infinity minus Z. Here in the denominator, take minus outside, 1 plus W. So W minus 1 by 1 plus W, or W plus 1, into 1 minus I by 1 plus I with minus sign, that is left hand side, minus of 1 minus I by 1 plus I into W minus 1 by W plus 1, or 1 plus W, that is left hand side. In the right hand side, since there is infinity, take the coefficient of the infinity that we discussed earlier. Now coefficient of infinity is minus Z in the numerator. In the denominator, infinity into minus I, so it is minus I. Now cancel this minus sign, Z by I. Here 1 minus I by 1 plus I, multiply and dividing by 1 minus I, numerator becomes 1 minus I whole square, that is 1 square plus I square minus 2 into 1 into I, minus 2I. 1 square is 1, I square is minus 1, their sum is 0. So minus 2I with this minus sign. So 2I divided by 1 plus I into 1 minus I is 1 square minus I square. I square is minus 1. So 1 minus minus 1 is 2. So 2I by 2. 2I by 2 is nothing but I. Take this minus I left side. So minus I square. I square is minus 1. Therefore this becomes minus 1 and cancel minus sign. Therefore W minus 1 here minus this part becomes minus of 1 minus I by 1 plus I is nothing but I into minus I. So minus I square is 1. 1 into W minus 1 by W plus 1 equal to minus Z. Or W minus 1 is minus Z into W minus Z. And W plus WZ, or W into 1 plus Z equal to 1 minus Z. W into 1 plus Z equal to 1 minus Z. Therefore W is 1 minus Z by 1 plus Z. So this is another method how we can solve the problem, this type of problems, how we can find BLT by cross ratio method. But in some problem, this cross ratio method, it becomes very complicated to solve that one. Therefore I am going to stick on the first method, that means direct method. Just substitute in W equal to AZ plus B by CZ plus D and solve. So I am going to discuss the problems in by first method only. This cross ratio method, for some students this looks very easy. You can try this method also. Okay. One more example. Find the bilinear transformation which maps the points Z equal to 1 I minus 1 onto W equal to 0 1 infinity. When W is 0, Z is 1. When W is 1, Z is I. When W is infinity, Z is minus 1. By the first method, that means direct method, assume that W equal to AZ plus B by CZ plus D be the required bilinear transformation. Substituting the given points, W0, 0 equal to A into Z, Z is 1, A plus B by C plus D. 0 equal to A plus B by C plus D, and 1 equal to IA plus B by IC plus D. 1 equal to IA plus B by IC plus D. And infinity, W is infinity, take its reciprocal, 1 by W is 0. Therefore take this reciprocal, CZ plus D by AZ plus B. When W is infinity, take 1 by W, that is 0. 0 equal to CZ plus D. CZ, Z is minus 1. So minus Z is minus 1, minus C plus D by minus A plus B. Because as W tends to infinity, 1 by W tends to 0. From the first equation, A plus B is 0 into C plus D. Therefore, A plus B is 0. IA plus B is 1 into IC plus D. Therefore, IA plus B is IC plus D. Minus C plus D is 0 into minus A plus B, that is 0. So, minus C plus D becomes 0. Find two equations involving only 3 variables. Here A and B, so C is not there and D is not there. So, from these two, remove one of the variable. So, better remove D. D is nothing but C. By substituting D equal to C in the second equations, we got two equations involving A, B, C only. One is IA plus B equal to IC plus C, because D is C. IC plus C means C into 1 plus I. Take left side. So, it is IA plus B minus 1 plus IC. That is one equation. And one more is A plus B plus 0C. So, no C here. A plus B plus 0C equal to 0. And IA plus B minus 1 plus IC equal to 0. Take the coefficient, first B and then C and then A, again B. The coefficient of B, C, A and B, here 1 and here is also 1, 1, 1. C is 0 minus 1 plus I, A is 1 and I. Therefore, 1, 1, 0 minus 1 plus I, 1, I, 1, 1. Therefore, A is nothing but determinant of the coefficient of B and C, that is 1 into minus 1 plus I minus 0. Therefore, it is minus 1 plus I. And B is determinant of C and A, coefficients of C and A, that is 0 minus 1 plus I. So, that is 1 plus I. And C is 1 minus I. A is minus of 1 plus I, B is 1 plus I, C is 1 minus I. But B is nothing but, D is nothing but C. Therefore, C equal to D, that is 1 minus I. Now, substituting this A, B, C and D value in W, you get the required bilinear transformation. Here, A and B are same but in opposite sign. A is negative, B is positive. Therefore, from A and B, take 1 plus I outside. So, it is 1 minus Z into 1 plus I. Denominator C and D are equal. Take C outside. That is 1 minus I into 1 plus Z. Therefore, 1 plus I by 1 minus I into 1 minus Z by 1 plus Z. This is required W after substituting this. Because A is negative, B is positive, 1 plus I is taken outside, minus 1 into Z plus 1. Or 1 minus Z. Denominator C and D are equal, that is 1 minus I, therefore Z plus 1 or 1 plus Z. Here, multiply and dividing by 1 plus I, denominator becomes 2, 1 minus I into 1 plus I, that is 1 square minus I square is minus 1, 1 square minus 1 is plus 1. So, 1 plus 1 is 2, denominator becomes 2, numerator is 1 plus I whole square, 1 square plus I square plus 2 into 1 into I, 2I. 1 square is 1, I square is minus 1, 1 minus 1 is 0 plus 2I, 2I by 2, that is I into 1 minus Z by 1 plus Z. This is required bilinear transformation for this problem. Okay, one more example. See here, 1 plus I by 1 minus I is 1 plus I whole square by 2, that is 2I by 2 is nothing but I. Therefore, this is replaced by I. Next one, find the bilinear transformation which maps the points Z equal to 1, I and minus 1 onto W equal to 2, I and minus 2. When W is 2, Z is 1, when W is I, Z is I, when W is minus 2, Z is minus 1. Assume that W is AZ plus B by CZ plus D, that is the required bilinear transformation. By substituting the given set of points, we will get three equations. One is 2 equal to a into 1, that means a plus b by c plus d, that is first equation. And second equation is I equal to ia plus b by ic plus d. And one more is minus 2 equal to minus 1 into a plus b minus a plus b by minus c plus d. 2 equal to a plus b by c plus d because z is 1. So a plus b by c plus d and w is 2. And I equal to z is also ia plus b by ic plus d, and minus 2 equal to minus a plus b by minus c plus d. So it's very simple by just substituting the set of values of w and z. So you get three equations. A plus b is 2 times of c plus d. So a plus b is 2c plus 2d. Ia plus b is I square c plus id. I square is minus 1, minus c plus I into d. Minus a plus b is 2c minus 2d. Therefore, three equations are a plus b is 2c plus 2d, ia plus b is minus I plus id, minus a plus b is 2c minus 2d. Why it is 2c? Minus 2 into minus c is 2c, minus 2 into d, so minus 2d. So we got three equations. Now by adding the first one and last one, see this, add these two, a cancels, b plus b, 2b, 2d cancels, 2c plus 2c is 4c, 2b is 4c or b equal to 2c. So we got b equal to 2c. And similarly, subtract the first one and third one, 1 minus 3. So you will get a minus minus a, that is 2a, b cancels, c cancels, 2d minus minus 2d is 4d, 2a equal to 4d means a equal to 2d. And adding 1 and 2 times of the second, because I want the equation involving three variables, either ABC or ABD or BCD. Here adding 1 and 2 times of second, 2 times of second means C cancels. So you will get A plus IA, that is 1 plus IA two times of equation 2. So 2i into a, 1 plus 2i into a, 1 plus 2i into a, and b plus 2b, that is 3b, 2c minus 2c, because 2 times of equation 2, therefore c cancels here, right hand side, 2d plus 2id, take 2 outside, 1 plus id. Now this equation does not contain c. So we got two equations not involving c. Therefore we can write like this, a plus 0b minus 2d equal to 0. And here 1 plus 2ia plus 3b minus 2 times of 1 plus id equal to 0. So we got two equations not involving c. Start with b coefficient and then d and then a again b. So b, d, a, b. In the first equation 0, minus 2, 1, 0. 0, minus 2, 1, 0. In the second equation 3, minus 2 times of 1 plus I, 1 plus 2i and 3. Therefore a is nothing but 0 minus 3 into minus 2 is minus 6. 0 minus minus 6, that is 6. A is 6 and b is minus 2 into 1 minus 4i minus minus plus 2 plus 2i minus 4i plus 2i is minus 2i. Minus 2 minus of minus plus 2 cancels. Therefore, it is minus 2i. 3 minus 0, that is 3. D is 3. A, B, D. A, B, D. 6 minus 2i and 3. To find C value, either use the first equation or second or third equation and substitute the value of A, B and D. You get C. Since B equal to 2C, why B equal to 2C? By adding the equation 1 and 3, you get B is 2C. 2B is 4C or B equal to 2C. And C is nothing but, because B is minus 2i, cancel to minus I. C is minus I. So we got the value of A, B, C, D. Substitute in required BLT, W equal to AZ plus B by CZ plus D. Therefore, required bilinear transformation is 6Z plus B, B is minus 2i, divided by CZ, that means minus I into Z, plus D, that is 3. Or you can write like this: 6Z minus 2i divided by 3 minus IZ. So this is the required BLT. One more example. Find the bilinear transformation which maps the points Z equal to 0, minus 1, infinity onto W equal to minus 1, minus 2, minus I and I. That means when Z is 0, W is minus 1. When Z is minus 1, W is minus 2, minus I. When Z is infinity, W is I. Assume that W is AZ plus B by CZ plus D. That is the required bilinear transformation. Substituting the given points, we get minus 1 equal to 0 plus B by 0 plus D. That is B by D. Minus 2 minus I equal to Z is minus 1 means minus A plus B by minus C plus D. And I equal to Z is infinity. Infinity by infinity means just differentiate A by C. So it is A by C. Or you can write B equal to minus D. Minus A plus B is, take minus sign outside, 2 plus I, minus of 2 plus I into minus C is 2 plus IC minus 2 plus I into D. And one more is A equal to I into C. Now, is there any two equations not involving one of the variable? Here B and D, here A and C, here A, B, C, D, all are there. Therefore, how we can eliminate? Either eliminate D or eliminate B using the second equation, because in the third equation B is not there and D is also not there. Therefore, put A equal to IC in the second equation. Put A equal to IC. Then minus IC plus B equal to 2 plus IC minus 2 plus ID. Now A is eliminated. Or you can write like this: B, here B, and then 2 plus IC, take left side, minus 2 minus I, minus I. So minus 2 times of 1 plus IC, minus 2 minus 2I, that is minus 2 times of 1 plus IC, and minus, take left side, it becomes plus 2 plus ID equal to 0. Now this equation not containing A and first equation not containing A. Therefore, B plus D equal to 0 is nothing but B plus 0C plus D equal to 0. Therefore, C, D, B, C. Here C minus 2 into 1 plus I, D 2 plus I, B 1, again C minus 2 into 1 plus I. In this equation, B plus D 0 means B, C, C is 0, D is 1, B is 1, C is 0. So B, D, B, C. Now this cross multiplication, minus 2 times of 1 plus I into 1 minus 0, that is B. B is minus 2 times of 1 plus I, and C is nothing but 2 plus I, 2 plus I into 1 minus 1. 2 minus 1 is 1, 1 plus I, 1 plus I. And last one, D is 0 minus 2 times of 1 plus I. 0 minus 2 times of 1 plus I is 2 times of 1 plus I. Here 1 plus I is common, cancel it. Therefore B is minus 2, C is 1, D is 2. And A is I into C. C is 1, therefore A is I. Substitute these values in this W. So required bilinear transform is AZ. A is I Z minus, plus B means B is minus 2, so minus 2 divided by CZ. C is 1, 1Z plus D. D is 2. So this is the required bilinear transformation. One more example. Find the bilinear transformation which maps the point Z equal to minus 1, I, 1 onto W equal to 1, I minus 1. Same logic. Assume that W is AZ plus B by CZ plus D be the required bilinear transformation. Substitute these points. 1 equal to minus A plus B by minus C plus D, because Z is minus 1. I equal to IA plus B by IC plus D. Minus 1 equal to A plus B by C plus D. Now from these three equations, to find A, B, C, can write minus A plus B is equal to minus C plus D. IA plus B is I square C, that is minus C plus ID. A plus B is minus C minus D. If you add the first and third equation, A cancels and D cancels, B becomes minus C, B equal to minus C. When B equal to minus C, cancel B and minus C, IA equal to ID means A equal to D, and here minus A equal to D. A equal to D minus A equal to D. That means A plus D is 0, minus A plus D is 0 means A and D both are 0. See, if you add these two, 2D is 0 means D is 0. When D is 0, A is also 0. Since A and D are 0, just substitute in W A and D. So this becomes 0. B by CZ. W becomes B by CZ. But B is minus C. So minus C by CZ. W is minus C by CZ. Cancel C. So minus 1 by Z. So this is the required bilinear transformation. So W is minus 1 by Z, because for any B, B is minus C for any C. So cancel C, so we get W is minus 1 by Z. Now one more example. Find the bilinear transformation which maps the points Z equal to 1, I minus 1 onto W equal to I 0 minus I. Under this transformation, find the image of mod Z less than 1. Also find the invariant points. Now, when W equal to AZ plus B by CZ plus D, by substituting the given points, I equal to A plus B by C plus D, 0 equal to Z is I, therefore IA plus B by IC plus D, and minus I equal to Z is minus 1, therefore minus z plus b by minus a plus b by minus c plus d. So we got these three equations. Or you can write a plus b is ic plus id, ia plus b is 0 into anything is 0, so it is 0. Minus a plus b is minus plus ic minus id, plus ic minus id. If you add the first and third equations, a cancels, 2b equal to 2ic or b equal to ic from the equation 1 and 3. So we got b equal to ic. In the second equation, ia plus b equal to c, 0. So we got the two equations not involving d. Therefore, b equal to ic and ia plus b equal to 0. Using these two equations, you can write like this: b equal to ic means 0a plus b minus ic equal to 0, and ia plus b plus 0c equal to 0, because no c in this equation, second equation, therefore write it as 0c. First start with b and then c and then a. Coefficient of b is 1 and 1, c is minus I and 0, a is 0 and I, again b is 1 1, 1 1 minus I 0, 0 I 1 1. The value of a is 0 minus plus I, 0 minus I, that means plus I, and value of b is minus I square minus 0, minus I square is 1, c is 0 minus I, therefore a is I, b is 1, c is minus I. And to find the value of d, either use the first equation or the last equation. In the first equation, I into d is a plus b minus ic, a plus b minus I into c, minus I into c, c is minus I, into I is plus 1, a plus b, I plus 1 equal to 1 plus id, cancel 1. So id is I, therefore d is 1, id is I. So b is 1, b is 1, a is I, minus I into c is also minus I, minus plus I square, that is minus 1, 1 minus 1 cancels, so id is I, d is 1. Now substitute the value of a, b, c, d in w. So iz plus b 1 plus iz divided by d is 1 minus iz. So w is 1 plus iz by 1 minus iz. To find the invariant points or fixed points, replace w by z. When w is z, so z equal to iz plus 1 by minus iz plus 1. Now to arrange, minus I into z square plus z equal to iz plus 1, or minus iz square plus 1 minus iz minus 1 equal to 0, or you can multiply throughout by minus sign, or multiply throughout by minus I. Minus I into z square, multiplying by I, throughout multiplying by I, so you will get minus I into I is minus I square, that is 1 z square, minus I into 1 is multiplying by I means 1 into I minus I square is 1, therefore 1 plus I z, multiplying by I means minus I equal to 0. Z square plus 1 plus iz minus I equal to 0. Az square plus bz plus c. A is 1, b is 1 plus I, c is minus I, and hence z equal to minus b is 1 plus I, plus or minus root b square 1 plus I whole square minus 4ac, 4 into minus I, minus 4i, minus plus 4i, 1 plus I whole square is 2i plus 4i, So it becomes 6i divided by 2a. A is 1, therefore divided by 2. Now we know that 1 plus I whole square, 1 plus I whole square is 2i. 1 square plus I square plus 2 into 1 into I, that is 2i. 1 square plus I square is 0, I square is minus 1, 1 minus 1 is 0, 2i. So 1 plus I whole square is 2i, into 3 is 6i. 6i can be written as square root of 3 into 1 plus I whole square. Now it is nothing but root 3 into 1 plus I. Take 1 plus I common outside. Here minus 1 plus or minus root 3 into 1 plus I divided by 2. So this is the required invariant points. And one more question is there to find the image. To find the image modulus of z less than 1. If w is az plus b by cz plus d, then to find the z value in terms of w, z becomes just to interchange a and d and change the sign of b and c. Here a is I and 1 interchange. So z here, instead of z you write w, here I, w, here I, and change the sign. C minus I, change the sign. So it is plus I into w. And b, here 1, change the sign. It is minus 1. So z can be written as w minus I minus 1 divided by I into w plus 1. Mod z less than 1, to find the image of mod z less than 1 means the interior of the circle mod z is root x square plus y square. Less than 1 means x square plus y square is less than 1. X square plus y square is equal to 1 means circle, and x square plus y square is less than 1 means interior of that circle. Mod z less than 1 means w minus 1 by I into w plus 1 modulus is less than 1. And I modulus of I is nothing but 1. Modulus of I is 1 and w plus 1 modulus remains. Therefore, w minus 1, numerator here w minus 1, w is u plus iv minus 1. Therefore, real part becomes u minus 1 plus iv. Denominator modulus of I is 1 and w plus 1 is nothing but u plus iv plus 1. So take this denominator right side. So it is into 1 means modulus of I into modulus of u plus 1 plus iv. Now we know that x plus or a plus ib modulus is square root of a square plus b square. Here a is nothing but u minus 1, b is v. Therefore, square both sides, you get u minus 1 whole square plus v square, that is modulus whole square, less than modulus of I is nothing but 1, u plus 1 real part, a is nothing but u plus 1, its square plus v square. U square minus 2u plus 1 plus v square less than u square plus 2u plus 1 plus v square. Cancel v square, u square and 1. Minus 2u less than 2u. Minus 2u less than 2u means 4u is greater than 0. 4u is greater than 0 is nothing but u is greater than 0. Now u positive, u greater than 0 means in w plane, u positive means it is right side of the plane, right side of v axis. That means half of the w plane, that is right side of the v axis. Therefore, the image mod z less than 1 interior of the circle x square plus y square equal to 1 in z plane is u greater than 0, that is half of the w plane, right side of the v axis. So this is about bilinear transformations. I hope you got the idea, this method. You can solve the same problem using the cross ratio method also. In the next lecture in module 2, so I am going to discuss about complex integrations. Thank you for watching.